UPS में, like I was doing each and everything. I was involved in each and everything. So here I am least involved. All these guys are brilliant and they are doing so many things. I mean, at their own. Research point of view, they all have great potential. But the only thing we need to give them little time. Papia, yes or no?
Of course, yes, sir.
And where
Of
is your
course.
HD?
Actually, ma'am, HOD ma'am is busy with some urgent meeting with IQAC. So that's why she couldn't.
I was also in IQAC meeting and this is opened on a parallel laptop. So I just asked her that she can join for 10 minutes and then
That will be really nice if she can join.
so
Nice to yes.
तो सर ओमान में I mean research का क्या है वहाँ पे in your institute?
In Oman, in our institute, we are working on various projects funded from government of Oman. Mainly, they are working in the field of water and the purification of water.
Okay.
Using membranes. People are also working in electromagnetic radiation measurement. So they are actually working really on the problems which are really related to life. The government is actually promoting these areas in which they can solve the problems of the society, solve the problems of the industry, basically. So, and they have a very good platform on which industry as well as academia and research organizations can join together. The industry can throw the problem, the academician can catch up the problem and suggest a solution. Based on that suggestion and the acceptance of that solution, the money can be given to the organization for solving the problem.
Very nice.
They have made a very good platform.
Most of the research is like directly related to the field. I mean,
yes.
Because that is essentially required even in India, because here success rate is measured by how many publications one has done and how many PhD student people have obtained.
Yes, that's very true.
Here actually, whenever the DST project or other projects are there, we are just showing them that we have published 10 paper out of it and 2 PhD students, and it considered it's a successful. We submit the PCR and all, but I think that approach is really essential for Indian prospectus also.
Really true. And I think in India also things are becoming little better. I'll show in my talk also a little bit of glimpse of that thing. और वो आप सब तो जानते ही हैं, आप इस फील्ड में लगातार जुड़े हुए हैं बहुत सालों से. But अभी समय लगेगा शायद.
It will take time.
It will take time. बड़ा सिस्टम है.
So Papia, I think we can start, and it's okay. I mean, see, in physics discipline, you should not expect more than 20-25 people. This is physics.
Yes.
Right? If it was some design or some media or something, you could have seen 100 people here. So
there also definitely another point is that they have exam from next week. Maybe for that they are little.
No, even though Dr. Pandey, the talk is based on physics, but I will try to use as low as possible this word physics.
Yes. So our students have joined or not? I mean, this is most important thing, right?
Mostly.
Okay, and all our physics faculties are also there. So I think we can start.
Okay.
Okay. So first of all, welcome and good morning to everyone present here. And of course, I would like to welcome our respected speaker, Dr. Piyush Dua here. We are really fortunate to have you here, sir, because sir already introduced you in front of us. Means in not the official official platform unofficially, and I can understand that what we will get today. And obviously, our students are really fortunate to have you. They can listen from you. Thank you for your time, sir. So I would like to welcome and good morning our Dean, sir, Dr. Jitendra Kumar Pandey, sir, who's the Pro Vice Chancellor, Research and Development at Adams University and Dean of School of Basic Science, Basic and Applied Sciences. I would like to welcome our senior professor, Dr. Aparajita Bhattacharya, Dr. Professor Somnath Chatterjee, and Dr. Tamal Kumar Mukherjee, and all. And I would like to welcome our HOD, Madam, Dr. Momita De, in this webinar. So, actually, really, I would like to welcome our participants. Without them, it was really impossible to organize. So I would like to welcome all of you, all the participants, and thank you for taking the time off to join these deliberations. So without wasting time, I would like to request my colleague, Dr. Swarup Kumar Neogi, sir, so introduce our respective speaker and to start the talk.
Okay, thank you, Papia. I am audible to everyone?
Yes, sir, you are audible.
Okay.
Yes.
Good morning, sir. Good morning, Dean, sir.
Morning.
And I am really happy and to introduce in front of our students. I am Dr. Swarup Kumar Neogi from Department of Physics. I am working as an assistant professor there. So, Professor Piyush Dawa, which is our respected speaker today, has a very long academic journey. He received his PhD degree from Indian Institute of Science, Indian Institute of Technology, Roorkee, and later he is going to postdoctoral research work in Korea, Pohang University of Science. After that, he joined as an academic position in several universities like Amity University, Noida, then University of Petroleum and Energy Studies in Dehradun. And at present, he is now working at the University of Technology and Applied Sciences, which is under Ministry of Education, Ministry of Higher Education, Oman. During his academic journey, he received several awards and projects like from BRNS, AICT, and his work is also very much interesting and getting published in several international journals of very high impact factor like Scientific Reports, JPCC, Chemistry and Sustainability, and others. So, in addition to this, he has received several awards like he got selected as a category A speaker by DST Government of India in a seminar which is named as TPSC in the year 2005. And he is also received the Asia Award. In addition to this, he is also very much involved in mentoring students who are basically taking part in international competition like which was been organized by NASA USA. So in brief, I have introducing Professor Dawa's academic career. In addition to this, I would like to mention that he is also very much fond of playing table tennis. So I would like to request Professor, please start your lectures and enlighten us with your ideas and with your views and sharing with us with some experience. Thank you, sir.
Thank you, Dr. Swarup, for a kind introduction. It was very nice. Thank you, Dr. Papia, for coordinating this meeting, and special thanks to Dr. Pandey for giving me this opportunity to share my work and share some experience with all the audience. So without taking time, let me share my screen.
Sir, Swarup sir, I would like to request to mute. Swarup da, can you please mute? Okay. Okay,
I
sorry,
hope
sir.
my screen is visible.
Yes, sir, completely.
So once again, I would like to thank the organizers for giving me this opportunity to talk upon the topic future career prospects in physics. As I was telling that I'll try to use as minimum as possible the word physics. So taking into the emerging and thrust areas, as Dr. Sarup mentioned that I come from University of Technology and Applied Science, Sohar, Sultanate of Oman. This is an organization which is working under the Ministry of Higher Education. And nowadays we are also engaged in the research which is really related to the industry problems and the problems related to the society. Especially the water is one of the hot areas in which one of my colleague is working. And there are a few other areas on which we are working, and that we can discuss later on if we have any possibility of working together. So to start my talk, generally we have this question at the student level that which stream or subject is important and where should I go? So to answer that question, let us try to explore what options do we have. During my talk, I will go through these outlines, how quality of life improves, latest trends, nanotechnology, which is, I think, nothing new in that, but I'll give a few minutes to this topic before moving forward to the other emerging areas. Memristor, quantum computer, and at the end, I'll go for DNA computing. So, first of all, how quality of life improves. Dr. Pandey is coordinating all these things. He knows all these things in detail for last few years. So the research is being conducted in the lab, then the intellectual property is gained, then it goes to prototype, and after protection, it goes to the improvement of life. Very simple process, nothing new in this. And then after this profit, some more money can be given to the people, those who are having innovative ideas, and this cycle goes on. So the contents of the improvement of lives are moving research into practical use, giving money those who are having idea, and to get the intellectual properties. And then benefits are being shared among the investors. So as far as the intellectual property is concerned in terms of patents, Dr. Pandey and we were discussing this point. This is a list of 2020, and IBM is leading this list with close to 9,400 patents in 1 year. And top 25 companies are listed. There is no company from India at the moment as far as 2020 list is concerned. So that is the target, as Dr. Pandey and we were discussing, that we should have the problems of real life, problems of the society, which are really going to improve our life. In addition to the basic research, we should also try to identify those areas in which we can have the patents. Let me give you a very close comparison of three neighbors: India, Korea, and China. So if you see this tally, this highest tally is having 1 million patents in one particular year. This is from China. China is having almost similar population as India. Korea is having highest tally here, 2 lakhs, and having population 4% or 5% of India. And India is having highest tally, 40,000. So here we are in the year of 2015. And in 2019, the situation is that India is here and China is leading with a great margin. So we should try to work out so that we can have the patents to reduce this margin. Now, to do this, we should have something different approach, which probably we were not following in last 40, 50 years. The reason is we are having science and technology working in a separate lab, working in a separate zone. And that's why a happiest person is a person who is having no husband and no mother-in-law. Either you can take it as a science or technology. Those who are having the alone life or simple life, they are happy. But we know that marriage is a requirement of life. So a great marriage is not when the perfect couple comes together. It is when an imperfect couple learns to enjoy their differences. We say that science is more important. We say technology is more important. Everything is important. The only thing, and you will join hands. So I prefer always to have the shake hands of science and engineering. And then only we can have a technology transfer. Otherwise, we will have the same margin as you have seen in the list. So let me give you an example. This is a very famous example of having gold nanoparticles in different test tubes with different colors. If a scientist is having this type of setup in his lab or in her lab, if industry does not come to take this concept, this scientist cannot earn money. This technology will die in the lab and nothing will happen as far as the technology transfer is concerned. So let me show you some areas in which you can see these two words together means science and technology. Biophysics, nanomechanics, these are all the words which we have heard in our daily life or in magazines or TV debates. Bioelectricity, biocomputing, artificial intelligence for chemistry, artificial intelligence for climate change, DNA computing. DNA is a term coming from biology. Computing is far away from that area. But this is the term people are using, and it is a reality nowadays in which people are working. Another example, artificial intelligence, people think that is working only for problems which are related to the computing people. But actually, artificial intelligence is also involved to solve the problem of organic chemistry. So the areas of science and engineering are having a lot of things which can be find it common, and people can work together to find out various solutions as far as the industry or the life is concerned. So to take you forward, I will talk about few things, nanotechnology, which is, I think, everybody is aware of, nothing new about it. Memory stir, quantum computers, DNA computing. To start with nanotechnology, it is a material in which we have a length or the dimension is 1 to 100 nanometer. Quite obvious. As far as 1 nanometer is concerned, if we keep 10 hydrogen atoms in a line or almost 7 silicon atoms in a line, it will cover a 1 nanometer area or distance, length. Richard Feynman in 1959 has given this a statement that there is a plenty of room at the bottom. A lot of applications are there which are being used in our daily life. I will not go into the details. And actually, these applications are now becoming our base of life. Various examples are available in nature. Let me show you. Atoms are everywhere. As far as air is concerned, body, food, laptop, mobile, all living and non-living. So if everything is coming from our periodic table, everything starts from chemistry. Then only other things are coming into the picture. The reason is, if we have this material, the chemist can see this is a bunch of atoms sitting together to minimize the energy. For a biological person, this is a molecule of some biological entity. For physics people, it is the combination of atoms which are having band gap in some way, whether it is metallic or semiconducting or insulating. So the same thing is being seen through different angles, through different eyes, through different goggles. So we, as a physicist, look at this material from the eyes of physics. So that is the only difference. Playing with small can make you big. In 1989, IBM has started playing with atoms. And that's why I'm showing you the list again. In patents 2020, IBM is leading the tally. For last few years, IBM is leading this tally because they started playing with small things. Those who are people from computing background or computers background, for them it is very difficult to understand why IBM is playing with atoms. Real life. We have from Vivo a processor in the range of 10 nanometers. This is real life we are using. Exynos is using a chip which is having a functional area of 5 nanometers. So 5 nanometers is nothing but in a line if we have 35 silicon atoms, or in a bunch of system in a physical device, it may be around 150 to 200 atoms. So atoms are the part of our devices. That is the device which we are using, and the industry is able to control the organization of all those atoms to make a device which can function in a very controlled manner and as per the desired conditions. So as far as this field is concerned, it is having a lot of money involved in this. A lot of projects around the globe are going on in almost all the countries. A very huge funding is being provided for last 20 years, and still it is going on because a lot of products and lots of innovations are coming through this field of research, which is called nanotechnology. One of the examples of the nanomaterials is carbon nanotube. So again, this carbon nanotube is a chemical entity. For a chemistry people, it is a simple material which is having a lot of chemical properties. For a mechanical engineer, it is like a bearing, which is having tubes which can move in a controlled manner. For a physicist, it is a metallic. It can be metallic, it can be semiconducting, it can be insulating. For biological people, this is a material on which he can attach a drug and he can give it to the patients for the target drug delivery. So ultimately, a material is same, but we have different eyes to look upon it. That is the thing. And that is the point where I was starting, which subject is important. Whatever subject you take, to understand this material, you can do it. As far as carbon nanotube is concerned, it is very light. People are using in spacecrafts. People are using to coat the surface of the cars to make it strong without increasing its mass or weight. The electrical properties, it can be metallic, it can be semiconducting, depending upon the synthesized conditions, we can have different electrical properties. And it is more conductive than copper, and it is more strong than steel. So this is one of the examples of thousands of nanomaterials available. Why I'm taking this? Because the next few topics are actually related to the nanomaterials and nanotechnology. So as far as the future is concerned, up to now, for last few minutes, I was talking about the past, I was talking about the present, and now I will take you where the prospects are available in terms of physics area. For that, let me show you Moore's law. Moore's law is a law which is given by the founder of IBM, Moore. He observed that it is an observed rule. It is an observed law. It is not a physical law. He observed that the number of transistors on a particular chip, for example, 2x2 chip. For example, I can have 10 components installed on a 2x2 chip. In next 18 months, the research and development will take the size of the components in the direction so that it will be small, and after 18 months 20 transistors or physical components can be installed on a same chip. So in other words, the number of transistors or the integrated number of components can be doubled in every 18 months. So for the last 5 decades, the industry is following this Moore's law, which was given in 60s. As I mentioned that right now we are in the zone of 10 nanometers of or 5 nanometers. So this is the physical device, and this 5 nanometer area is the functional area. So to have very small components, we should have wires also, which are even smaller. So to have a nanowire in the range of 1 nanometer or 2 nanometer, it is very difficult to sustain it in the real environment, the open environment in which we live. So somehow the limit of miniaturization of components has been reached. And that's why people from industry are now saying that Moore's law is going to be end. This is a statement from the NVIDIA's CEO. Some more people are talking about this, that end of Moore's law is very close. So the question is, if the miniaturization of the components is going to be finished, what is the next in which industry is going to take steps so that the development can continue? Those are the areas which I'm going to share. So again, just to give you a recall, we are in the zone of 5 nanometers, but this is the limit. So now we are moving into the era of multifunctional materials and devices. So we are talking about all-rounders in cricket team, in which we have Spintronics, memristor, quantum computers, and DNA computing, which can continue the field of development even though the size of components are not going to be make more small. So Spintronics is an area in which people are investing a lot of time and money. So to make it understand, we know that the RAM of the computer is made of semiconductors. The hard disk or the memory device is made up of magnetic materials, especially ferromagnetic. So now to make it multifunctional, if I can have a material which can work as both semiconducting and magnetic properties, so in that case, I can replace a simple material which is having spintronic properties to have both the functionalities of RAM and hard disk. I can store the data and I can use as a RAM as well. So now DRAM can be converted into MRAM if the material is having the controlled properties of semiconducting and magnetic. So this field is known as spintronics. So spin is coming from the spin of the electron, and tronics is as usual. So the idea is that information is stored into the spins as a particular spin orientation, the spin being attached to the mobile electrons, and then that electron can carry the information along the wire. So conduction can become along with the attached memory. So the purpose is to control the movement of the electron so that it cannot flip its orientation during the journey. So spintronics can one of the areas in which the future is there. Try to note it down, a few components of this field. Try to explore, and you will find a lot of things are being done to solve the big problems of the industry. Because the spintronic material can give you some assurance that electronics, magnetics, and photonics can be merged together. So ultimately, whatever field you have, you can come through the branch of photonics, you can come through the branch of magnetic materials or electronics, you can contribute in the development of these spintronic materials. One of the important thing is that to generate the magnetic field, to generate the magnetic field is not required. It can be done with the help of electric field only. That is the beauty of the spintronic materials. Now, I'll move on to the another topic. Before that, I would like to have a small question from the audience, especially students, that how many passive components do you know? Anyone, please? Passive components like, for example, a resistor is a passive component, right? So please share your answer. How many passive components do we have?
One of our student, BSc student, he answered diet.
Okay.
Diet is one.
Okay.
Anyone you can answer.
3 components. Very good answer. Capacitor. Right. So we have a resistor, we have capacitor, we have inductor. Anyone else? Right. Resistor, capacitor, inductor. Do you know there is a 4th one? Let me show you how it has been introduced and how it can be used in coming years. The name is memristor. Memory plus resistor. It is an integrated part of the device. So we know that every device works on 4 parameters: electric current, voltage, charge, and magnetic flux. Okay. So voltage, current, flux, and charge. If we connect V and I, we get resistance. If we connect phi and I, we get inductor. If we connect Q and V, we get capacitor. 3 passive components, right? 2 physical laws. These are all known. Now the question is, what about this combination? So if we have 4 physical quantities, or simply 4 teams, those who are going to play league, there should be 6 matches to complete the league. So there should be a 6th term that should be there, which should be connected between charge and flux. So in 1971, a professor from Berkeley has given this term called memristor. And in 2008, this physical memristor was shown to the world with the team of HP. HP Labs has shown this physical device through a publication in Nature, and the title was very interesting. The title was Missing Memristor Found. So it was already there somewhere in the system, and the people from HP Lab has given the title Missing Memristor Found. Now, what can be done with the help of this memristor? So first of all, it completes the combination of charge and flux. So when we have charge flowing into the circuit, the resistor or resistance is changing in such a way that it can remember its past, means how much charge has been flowed through the device, that can be remembered with the memoristive device or memoristor material. So we have both memory and conduction through the same physical device. So we have IV characteristics. No other than memoristor device can show IV characteristics as a cusp. That was the question HP people were searching about for about 4 to 5 years, that how we can have a closed loop as far as IV is concerned. We used to have it for MH2, right? But it is IV curve. So in case of IV curve, they have never seen a closed loop. Later on, when they searched, they reached to the paper of 1971 written by Leon Chua, and then they came to know that they have made the memristor. Actually, they were trying to make non-volatile memory, but later on they found that they have made memristor. And a lot of materials are having the properties of memristor. A big list is there. I have published a paper that can be followed for the list of materials which show the memoristing properties. Now, what it can do? We talk about.
Excuse me.
Yes,
Actually,
please.
one of our students is asking to repeat the memory part. Maybe
Okay.
he wants to understand
Yes,
more
yes, yes.
clearly. Thank you, sir.
First of all, this memoristance is nothing but a resistance with memory. So M is having the units of resistance actually. Okay. So it is a resistance. But to make it difference, the name M is given because it remembers its the charge flowed to the system. Okay. What does it mean? If you see this IV curve, the voltage is increasing, the current will change. Okay, the current will change because charges are flowing. So that movement of charges can be remembered by the device. Now let me explain in a very simple manner. If you have a physical device, you make it switch it off, then you will make it on once again. The curve will start from 0, 0. What does it mean? The curve will have 0 current on 0 voltage, right? But in the case of memristor, if you switch it off, then it will turn on with the same memory as it was having before switching off. Now, as a human being, when we sleep, we go in hibernation mode. I think students know what is hibernation in computers. Yes or no? Hibernation in computers. Yes, good. So when we sleep, we go in the hibernation state. What does it mean? When we got up, we have all our memory intact. So here we have something which is working like a memory stick, right? So if we have a physical component which is having properties which can be compared with the neurons of mind, a big opportunity is there to use it as a functional device of robotics and artificial intelligence. Because to make the device smart, we should make it smart through two different ways. One is the software way, another is the hardware way. So installing memory-sticking devices into a chip is a hardware way to make it smart, which is sustainable, because software can be, you can say, hacked. Software can have some bugs, but once the hardware is there, the things are intact, sustainable. So I'm not challenging the software way, but this is the hardware way, one of the options available to make the device smart. So if you go to the examples, new system can help machines think like humans. So this physical component memristor, if it can be installed in the machines, because it is having similarities to the neuron of human mind, the machine can think like human. Engineers put tens of thousands of artificial brain synapses on a single chip. This is memristor. Nothing else. Organic memory device show promise for flexible, variable, personalized computing. Physicists create device for imitating biological memory. So now the important part, why I was talking about nanotechnology before this part. Memristor was there because HP people say that missing memristor found. So where it was missed? Actually, every physical device is working on these 4 parameters. So it should be an integrated part of every device. But till now, the magnitude of memristor was so small that it was not affecting the calculations. So the calculations were being done in absence of memristor, and we were able to compute all the properties of the devices along with these 5 combinations. So as soon as we go in the era of nano devices, the memristor comes into the picture because memristor is inversely proportional to the dimension square. So if we have a device with 10 nanometer, let me show you. If we have a device with 10 nanometer functional area, it is having, for example, M1 memristor. If I go to 5 nanometer chip, the size has become half. The memristor will become 4 times. So when we are in the era of nano devices, the magnitude of memristor becomes significant, that without memristor, if we compute the properties of device, it gives error. So memristor was there. Even the tube light you are having in your room is having memristor. but the magnitude is so small that we do not bother. But if you make your device with the help of nanomaterial, which is in the range of 5 to 20 nanometers, you have to have the contribution of memristance into your computational part. Otherwise, you will have dissimilarities in your experimental and computing data.
Sir, one of questions asking by Sobi, a student, is asking that is it in like flip-flop memory in a smaller dimension? I mean, can we compare like this way?
Flip-flop is even having dimensions in microns. Even this flip-flop, if you will see, it will have memristance into it, but the magnitude would be very, very small. For example, if I take the concept of gravitation, okay, the electron is having mass, but we do not bother about its gravitational force, mg, in our calculations, because mg is very small for an electron. But if we are talking about a device, physical device, or a ball, we have to bother about its weight, mg. So in same manner, the memristance is there because these 4 quantities are there in each device. So memristance should be there. No need to put it from outside. It is the integrated part of this device, of any device. But when we make a device using VLSI design and we compute the properties to make it as a part of, for example, mobile or laptop or any physical component. So we never take an equation in which memristance is there. So we take all these 5 and we get very good results as far as computing results and the experimental results are concerned. And the device is launched and we have been using the device very accurately, very efficiently. But now the size of the component is so small that the memristance part cannot be ignored. It is still there, but now it is grown up because of this small size. So now it cannot be ignored. And that's why people are getting this particular physical component into their devices to make the device smarter, because the properties of neuron are something like this: memory with conduction. In our minds, we have synapse which connect the neurons. Synapse is the entity which connect two neurons. So if you have a message passing through, it is just a signal which is passing through from one neuron to another neuron, right? So synapse is the entity which actually connects the neuron. So overall combination is very much similar to this. So wherever you have this closed loop, it means there is a memory. And in our mind, we know we have memory. So a same physical device, which can have both conduction as well as memory. And that's why people are thinking that to make smart machines using memristor. And once again, I would like to tell you that the first word memristor, as far as a physical device is concerned, was told by HP in 2008. But as a mathematical explanation was given in 1971. And after that, Professor Leon Chua and his team has worked, a lot of work have been done by their team. Now the question is, can't the components in the memristor be unified by a single equation? Yes, The equation is having now just a contribution of this term, which was ignored earlier. That's all. Right? Okay. Now, see where I am in 2019. First, programmable memristor computer aims to bring artificial processing down from the cloud. So artificial intelligence is a property which can be built up through hardware route if memristor is being used. Otherwise, we talk about artificial intelligence through software route. Okay, so now let me give you one example. If you have a robot which is taught properly to serve a cup of tea to the guest, right? Now you have same robot in which memristor is installed. Now the robot comes to serve the tea, and because of any mistake, the tea has fallen down on the table. Now robot does not know how to clean it because it was not programmed. So it is a software part which was not programmed how to clean. Now the person who is near that area cleans the table. If memristor is installed, it can learn. And next time, if he goes through the same situation, the robot itself start cleaning. So that is the way to make the device smarter through hardware route. Through software route, it has to be programmed that if you see such situation, you have to clean. If it is not programmed, it will not be done by the robot. So that is the difference. Okay. Any other doubt or comments or queries as far as memristor is concerned? We won't need cloud memory, then memory will be like an elemental property, but would not it be volatile, easily influenced by external electromagnetic or electromagnetic fields. Before installing into a device, it has to be tested properly, that how much external electric or magnetic field it can tolerate. Like, for example, the processor which we are using, it has the limit. For example, if temperature goes beyond a limit, the functioning will be disturbed. If we keep our laptop in a very high voltage, in high electromagnetic field, the functioning may be disturbed. Same thing can be happened with the memristor, because you are not changing anything. You are just adding few components which are having memoristic properties. The rest is same, right? Okay, so moving forward, quantum computers. So we know that all the quantum, all the computers work in the limit of 1 and 0, right? Anything which is having 1 and 0 switch on and off can be used as a material for the computers. So memristor is also one of them. They are actually switches. That's why they are being used as a part of computing devices. Now, what are the quantum computers? Apart from this 0, 1, if we can have a quantum state of 0 and 1, which can have both contributions. Okay, so in that case, the number of states which are actually 2, if we have one electron up, down, if we have one device, it can have 2 states, either switch on or off. So if we have the capability of electrons which can have intermediate state before flipping into up and down spins, if we can take advantage of those stages, the strength of the computers can be increased by 10 raised to power 12 times. I repeat, 10 raised to power 12 times. The concept was given in 2000, nearly 2000 by Indian origin person, Love Grover, and at the time, so many people have given the concept of the quantum computers as far as algorithms are concerned. So if you will search on the Google Grover's algorithm, you will find that the Love Grover was the person who introduced the concept of the quantum computing. Now, in last 4 to 5 years, that concept has been realized physically. Okay, I'm not going into the details how these are working, but the idea is to tell you that there is a field in which you can think upon to make your career. Why is it so? Let me show you. So IIT Madras to collaborate with IBM on quantum computing. 8 top quantum technology startups in India. These are the news of 1 year back. Okay. Quantum computing was the surprising feature of Union Budget 2020 when Finance Minister Nirmala Sitharaman dispensed rupees 8,000 crores towards the national mission of quantum technologies and applications in India. So this is a field in which government is investing. As far as China's 5-year plan is concerned, quantum computing is the highest priority area you can search upon in last 5 years plan of China. It is the highest priority area. Space is not the highest priority area. Quantum computing is the highest priority area. What is the reason? The reason is the speed of the quantum computers, the processing speed of quantum computers is so high that can be used for solving the problems at a very fast manner. For example, the problem of COVID vaccine. How or which material is good for making COVID vaccine? Quantum computing was used at background to make it very fast. And to solve the problem of, for example, the earthquakes, the problems of natural calamities, which does not give time to think upon. So all those calculations can be done in a very fast manner. These are the benefits, but there is another way in which we can find out the threats. The threats are, if you have your password, which is very much safe, and if I have an algorithm which can be run on a quantum computer, which is 10 raised to power even 5 times faster than a normal computer, not 10 raised to power 12. It can very easily find out the combination of your password. So cyber security is the area in which quantum computing is going to play a very huge role in coming years. Okay. So this is one of the areas you can explore upon. If you find it interesting, you can find out your way to contribute. DNA chip. DNA, we know, is a term used in the domain of biology, but we are talking about chip. Why? Because now DNA can be used as a material for computing devices. Now, may I request all the students to unmute themselves? Just for a moment, all the students unmute themselves. I'll ask a question. I expect answer from most of you if you know.
Yeah, 1 minute, sir, because I make them, I need to allow them for this.
Please, please,
Okay, with your permission, I have allowed.
please.
Yes, now you can mute yourself and can talk with Sir directly.
Okay. My question is, probably all of you have learned about DNA. Okay. DNA is having hydrogen on one side, right? One side is called trans and another is, yes, another is cis. All of us know we are people from physics background, right? Now you can please mute yourself. Okay. The idea was that as a person of physics background, we all know that DNA is having one orientation called trans, another called cis. And this is the requirement of a computer. One trans, zero cis, or vice versa. So if any material which can have two orientations can be used as a material for computers. And the speed, processing speed is in demand. So the flipping of trans and cis position is so fast, which is a requirement of the computer's people. So DNA is a material being looked upon from a physicist's eyes. It is a material like silicon. For biology people, it is a biological entity which is the essential part of life. But for a computing people, those who are working in the field of hardware, those who see this DNA from the eyes of physics, it is a material through which I can have high processing computing speed. One LB of DNA have more computing power than all the computers ever made. So that is the strength of the DNA computing. The only power needed is to keep DNA from denaturing. So unique energy problem is also getting, you can say, addressed if we have DNA computing. A DNA computer can solve hardest of problems in a matter of weeks. So the problems for which we need a very long time, the DNA computing or the quantum computers can solve the problem in a very small span of time. Right? So before going to the end of my talk, let us see the question once again. Which subject or domain is important? Even though I was talking that this talk is about the careers in physics, and I was also saying that I will use this word physics as small as possible. But we were looking the material from the physics or electronics point of view. Okay. So whatever way you want to adopt to contribute to make these devices, you can come from DNA background, biological background. You can come from carbon nanotube background. As a physicist, you can do everything. Without mathematics, you cannot do anything because it is a toolbox. Everything is material for a physics person. Whether it is a biological material or chemical material or liquid or solid, everything is a material, okay? And to develop the technology, you have to have some idea about electronics and electrical. And you should know the need of these people. Then only you can make something interesting which is required by the people of electronics, the people of electrical, and the people of computers. And the shake hand of the side of science and the side of engineering is a must to have something interesting in terms of the solving the problems and in terms of getting money back to invest for a next problem. So with this, I would like to thanks once again Dr. Papia and Dr. Pandey for giving me this opportunity to talk upon about this area of physics where no physics was there, right?
Yes, word was limited, but what I thought that everywhere the concept of physics, basic equations and concepts is incited. That's what I felt from your talk. Maybe the word physics was not uttered that way.
Yes, 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 yes.
Yes, thank you so much, sir. And whatever I think that you have discussed on memristors, quantum computing, quantum technology, DNA chips, DNA computer, etc., which are, I think, the new domain of concept. And now this is the age of multidisciplinary research. So we need to use concept. It could be biological, could be a mathematical concept. We need to use our basic concept of physics, and we need to connect it with some technology or industry. And I
Very
think that will make that will create the job vacancies in different domain. And that is the career prospect of physics, that what you are finding after your BSc physics or MSc physics. Is
so
it so, sir?
just to
Mhm.
convey the message from this,
Yes, sir.
you should have the wedding of science and engineering. Then only you will find
Yes,
which is really going to solve the problem of the society or the
yes,
industry. And
industry.
the domain is not uh, hindrance or hurdle. Why? You know, the Love Grover, who has given the concept of quantum computing, is a person from mechanical background from IIT Delhi. No limitations. Where quantum computing, where mechanical engineering from IIT Delhi. So he is a person from mechanical background, taken the problem of and very high level of mathematics and quantum physics is there if you are going to use the quantum computers. The memristor was proposed by Professor of Electrical Engineering. So no limitations. Stanley Williams is a scientist, but he has given the concept of memristor physically, but he was so involved in that that he has not said that he has developed memristor. He said missing memristor found. So the domain, whatever domain you are considering for your career, do it with full interest, but you should know where are the problems. Identify those problems, take your way, and give the solutions in your own way. As far as career is concerned, I think this is the best way out to move forward. I hope all of you will agree with these words.
I think there is no other questions.
Sir, can I ask a
Yeah.
question?
Yes, yes,
Okay.
please,
Yes,
please.
you can ask directly.
Sir, there are some, I mean, there are so many opportunities, but regarding our special subject, there are some limited, limited special subjects for our physics to research, like biophysics or condensed matter physics. Like, which one should we choose? Like, we don't know the later part, I mean, the later perspectives, but in the from the general point of view, when we will be just covering the basic physics, which steps should we take first?
Very true. The like we have to work in basics. That is, we should understand the basics. That is true. But those basics are actually going to become the base of the technology. Why I'm saying, if you will see this picture, which seems to be very simple, but a big message is there. The people from IBM, we all know that IBM is a company who is making computers, who is making the motherboards. But why are they playing with atoms? In 1989, still they are playing, and that's why they are leading. I have this tele to give you a proof that playing with the small things can actually make you big. So your base must be strong, but now once you have made your base, you should know that the concept of physics through which you are going to move, whether it is condensed matter physics or nuclear physics or biophysics or any other area, where do you want to go? Where are the problems? If you can give a material like DNA, the problem of energy is solved, because the computing power is so small that you have given a very big contribution. So the person who has introduced DNA as a material for the computers has given an enormous contribution in terms of energy, right? So try to identify the problems. Then only you will give your solution through your route. No need to change your domain if you are not interested. If you are interested, you are always welcome. But if you want that I will always do work in physics, but I will solve a problem of industry, you should know the problem. Every problem is having some part which is coming from physics, some part physics coming from electronics or chemistry or chemical route, whatever it is. But there should be a part of physics always, because all the subjects are always there. And that's why at the end, my message is all subjects are equally important. I cannot decide which subject is more important, because all are complementary to each other. So along with your basics, you should try to find out the applications. Now, to find out those applications, you can have research papers in which you can find out the use of those physical concepts. You can have talks or seminars among yourselves in which you talk about only applications. Okay, this particular concept of physics, in which device it is being used, in which field it is used, in which industry it is used, then only you will see that each law of physics is contributing somewhere. Now your device is going to be run through that physical law. So if you can improve the functioning of that particular component or material or device using that particular law, you can solve or improve the functioning of the industry. But you should know where it is connected. So that part will be learned in a very slow manner. But for that, the important thing is you have to start. Once you will start it, carry on your journey. It's a big life where you are going to contribute for next 40 years. You will have a lot of problems where you can contribute, but open your horizon to identify the problems. I hope
Yes, it is
this
very
is
much clear, I think. Sir, one last question.
yes,
It is
please.
asked by Jaya. Um, her query is, sir, please guide me about what is the nuclear physics domain available to switch some theoretical work that can be a continued resource in India.
The people from theoretical background in terms of nuclear physics, models have already been studied, but the reactions are being studied. At present, I'm sorry, I don't have enough information to share at the moment. But if you want, I can share this information later on, where you can find it interesting to contribute to theoretical channel in the field of nuclear.
Yes, you can write me so that I can convey your query to sir. That can answer you whenever he will find. Okay, sir. Any other question? No. Okay. So I think we have taken any other
Ma'am,
Kulnan. Yes, you may ask. Maybe we can take another question, sir.
Yes, yes,
Can we
please.
take, sir? Yeah, okay,
sir,
continue.
sir,
Yes.
the shift from government exams to these type of technologies, it's very rare. So how will we make the masses aware who are running after the government jobs to this part that you have a bright future in this area, this field? How will we do that, or won't it increase the unemployment rate?
Government is already aware of. Government is already aware of. You get the skill, you can be absorbed. For that, you can apply in CDAC. If you have this skill, CDAC is the entity which is working very actively in the field of quantum technologies. And all the research institutes, all the IITs and IITs, all the universities are somehow getting connected slowly, because in 1 year, 8,000 crores have been allocated for quantum technologies. This is year 2020 Union Budget, right? So in this year, it would have been increased. So government is aware of, government is calling you. You get your skill ready, come and contribute.
Thank you, sir.
Thank you, sir. Student, if I hope you don't have right now, you don't have any question. I am not finding anything in chat box. So can I request our Dean sir, Professor Jitendra Kumar Pandey sir, for vote of thanks? Maybe sir is busy in the other meeting. I couldn't. Sir, can I take another question?
Yes, yes, please.
Another question from Kaji sir.
Papia,
Yes, yes, sir. Yes, sir.
I think the rest of the questions you can write to Dua.
Yes.
Because
Okay.
it's already 1.5
Yes,
hours.
it's half an hour. So, Kaji, don't worry. I will take all of the question. You can write, all of the participants. You can write. I can send Dua sir for answer. Don't worry about that.
And
Sir, please continue.
I was really hoping that some of the students will ask, sir, how I can go to Oman for research work.
Yes, yes. Always welcome these queries. So whatever opportunities would be there, definitely I'll share, and students can explore. And then whatever I can do, I can contribute. Definitely, I will.
Sir, also
really, Papia, I think you can always keep in touch with sir.
Yes.
And
That's I was
and today you have taken 1.5 hours. This is Saturday, and he is on vacation in India. So you guys need to be little, flexible.
Sir,
So
yes.
Dua sir, thank you so much for your time, and I'm
you,
sure all my team they are very eager to get in touch with you. Maybe we can have some collaborative reviews, some research work, because there are a couple of faculties who are working in water area. I have been working in this area. I was not aware that water research is so popular. So there can be a possibility of a water network type of thing. India Oman water network. It need not to be very formalized, but through that network, at least we can connect. I mean, it's a long shot, but we can connect many people, and slowly we can start with working together. So this is
Definitely.
one possibility, and I just want to say thank you so much for your time. And when you are on vacation that is also very far from your hometown. So that's something very every team is whole team is very thankful that you have given so much time, and I can see the slides. You came very well prepared. So you invested your time to prepare the slide. So thank you very much. And I'm sure my team will keep in touch with you in case if they want to have any kind of suggestion or they want to have any kind of help from your end. So thank you, Dua sir.
Thank you, sir. Thank you. Thanks a lot.
Thank you.
Thanks to all the active listeners. And at the end, very positive comment I have got. Actually, I should say compliment from one of the students, I think. So thanks a lot for your appreciation. Please share your query, whatever you have. If I can contribute to give you some information, that would be very nice. So once again, I would like to thank Dr. Pandey for giving me this opportunity, Dr. Papia for coordinating the event so nicely, and all the audience for listening very efficiently, patiently, I should say.
Thank you, sir. Thank you very much.
Thank you, sir.
Thank you. Bye bye.
Thank you, sir.
Thank you,
Bye.
sir. Bye, sir. Bye. And I just want to add, I would like to thanks our IT support, IT team, Mr. Ranobroto Chanda, and also I would like to thank Mr. Chandrasil Tiwari for the nice prayer. Thank you so much, all of you, all the listeners, all participants here. Thank you, sir. Thank you once
Thanks a
again.
lot.
We
Thanks
will
once
be in
again.
touch. We will be in touch for any kind of collaboration work. Thank you so much, sir. Thank you so much.
Thank you. Thank you.
Thank you. So, with the positive thoughts on uninterrupted skillful learning and broad career path in physics domain, I am concluding this session. And have a nice day ahead. Thank you so much for your presence. Okay.
Okay,
Thank you,
Papia.
Dr. Sarup.
Okay.
Thank you, Dr. Sarup.
Thank you, sir. Thank you.
So I'm ending the session here.
Okay.
Regarding feedback form, I will send you all of you later with a registered mail ID. Don't worry about that. Thank you so much.